Hello students, let's continue with metals and non-metals, and we were discussing the chemical properties of metals and non-metals. So our next chemical property that we are going to discuss now, it is reaction of metals with other metals salt solution. Okay. Now we are going to discuss how metals they react with other metal salt solution, right. Now see here, this reaction it is based on the displacement reaction. It is based on the displacement reaction. Okay. Now what is this displacement reaction? See here, this displacement reaction is a very important chemical reaction in which what happens in this reaction, a more reactive metal displaces a less reactive metal from its salt solution. So displacement reaction is a reaction in which a more reactive metal displaces a less reactive metal from its solution form. Now how come we know that which metal is more reactive or which metal is less reactive? For this we have to refer to the reactivity series. So I will make the reactivity series here. Potassium, then sodium, calcium, magnesium, aluminium, zinc and iron, then lead, then hydrogen, and then copper, mercury, Ag silver and Au gold. Now see here, this is the reactivity series. Okay. So as we move down, the reactivity of the metal it decreases. Potassium is most reactive, whereas gold in this series is less reactive. See, you can see this hydrogen being non-metallic in nature, it is also placed along with the metals in the reactivity series because hydrogen has a tendency to lose electron and form positive ion. Okay. Now see here, now in the displacement reaction we can refer to the reactivity series. Now there is one rule for this displacement reaction, and that rule is the metals placed above in the series can displace those placed below in the series, Okay. Now just you see here, in the reactivity series of metal, potassium is most reactive, right, then sodium, then calcium, magnesium, then aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver and gold. Now see here, if we compare between aluminium and iron, okay, then which is more reactive? Aluminium is more reactive than iron. Similarly, when we consider zinc and iron, then zinc is more reactive than iron. That means zinc metal is able to displace iron from its solution form. Zinc is able to displace iron from its solution form, but iron will not be able to displace zinc from its solution form. So that is why see here I have written metal placed above in the series. So when we compare between zinc and iron, zinc is placed above in the series and iron is placed below in the series. So zinc can displace iron, but iron cannot displace zinc. Similarly, when we make the comparison between iron and copper, then you can see iron can displace copper from its salt solution, but copper cannot displace iron from its salt solution. Now let us study this property with the help of an example. Okay, we will take one example like, see here, we will take some copper wire and iron nail. We will take copper wire and we will take iron nail. Okay. Now, this copper wire, we will dip it in ferrous sulphate solution. Okay. We will put this copper wire in the ferrous sulphate solution and let us see what happens. Similarly, in case of this, we will dip iron nail in copper sulphate solution. Okay. Here we will take copper sulphate solution and we will try to observe what is the observable change. Okay. Now, just you see here, whenever there is a chemical reaction, we will observe some type of observable changes will be there, either evolution of gas or the formation of PPT, that is precipitate, or there must be some changes in the color, or there must be some change in the state, right. So, we will try to observe what are the changes here. In this test tube, we will observe that the blue color of the copper sulphate, slowly it fades. The blue color of the copper sulphate, it fades and changes to light green. It fades and changes to light green, that is the formation of FeSO4, right. FeSO4 is formed and copper is separated. Now, this copper is very easily observed in the form of reddish brown color deposits on the surface of the nail. Reddish brown color deposits on the surface of the nail, as well as at the bottom of the test tube also this deposits or reddish brown color deposit is observed in the bottom of the test tube also, that is copper is separated. Now, just you see here, but in this reaction there will be no change. In this reaction there will be no change. Now, just you see here, in this reaction between iron and copper sulphate, iron is placed above the copper. Copper here it is present in the sulphate form, the salt solution of copper, that is copper sulphate, and here it is iron. Iron being more reactive than copper, iron is very easily, it can remove the copper from its solution form and pairs with FeSO4 and it removes the copper and copper is separated. Because iron is more reactive than copper, so iron is able to displace copper from its sulphate form and form ferrous sulphate. But what about this case? See here, in this case copper and iron. Copper is present as a metal, whereas iron is present in its sulphate form. Now, copper, see here, copper is placed below in the series, and iron is placed above in the series. So, according to the rule, copper cannot displace iron from its solution form. Okay. So, no displacement reaction occur in this case, whereas the displacement reaction took place in the second case. Okay. This we can also, we will take another example also. One more example we will see. We will take some zinc granule. Okay. We will take some zinc granule, solid zinc granule, and put it in ferrous sulphate solution. Okay. In the next test tube, another one, we will take iron nail and put it in zinc sulphate solution. Okay. Now we will perform these two experiments. Now let us see what will happen. In this case, this is light green color. In the first case, what happens? This light green color fades and it changes to colorless. That is the formation of zinc sulphate and plus Fe, iron is separated, right. But here in this case, there is no change, right. Now again you see here in this reaction, in the first reaction, just see here, zinc is placed above iron. Okay? Zinc is placed above iron and iron is placed below zinc. So according to the rule, zinc can displace iron from its sulphate solution, but iron cannot displace zinc from its sulphate solution. Now that is why zinc has displaced. Zinc removed this iron from its sulfate solution and the iron is separated and the new salt that is formed is zinc sulfate. Okay. But in this case iron being less reactive than zinc. Okay. So here there is no reaction. So this is how the reaction between metals react with other metals in their salt solution. So this reaction is only possible when this metal is more reactive or placed above in the series than the metal which is present with their salt solution. Okay. So this is one chemical property of metals, and we will see another one, that is reaction of metal with other metals. Reaction of metals with non-metals. Okay. Now just you see here, in this reaction of metals and non-metals, right. Now why the metals and non-metal they react together? What is the reason why the metals and non-metal undergo chemical bonding and they form compound? Why do they combine together? They combine or undergo chemical bonding in order to attain stability. In order to acquire stability, the metals and non-metals they combine together. Okay. Now see here, or to complete their octet, we can also write, or to complete their octet, the metals and non-metals they combine together. Okay. We know that metals have 1, 2 or 3 electrons in their outermost shell, whereas a non-metal have 4, 5, 6 or 7 electron in their outermost shell. So to complete their octet, to complete their valence shell or to complete their octet, this metal and non-metal they combine together, right, and form compounds. Now just you see here, how can the metal acquire stability? How can a metal become stable? The metal can become stable either by sharing of electrons, or by transferring of electrons. These are the two possibilities with which the metal or a non-metal they can become stable. See here, whether it is metal or it is a non-metal, they are actually elements and they are made up of atoms. So whenever the metal and non-metal they combine together, means the atoms of metals and atoms of elements they take part in the bonding and they combine together. Okay. Now see here, sharing of electron we have already discussed when we were discussing carbon and its compound, isn't it? Carbon and its compound, in that chapter we have discussed sharing of electrons, and the bond form was covalent bond and the compounds were known as covalent compounds. Now in this topic we will be discussing the transfer of electron. We will be discussing transfer of electron, right. Now how the transfer of electron takes place. Now this metals have a tendency to lose electron. Metal have a tendency to lose electron, that is why metals are electropositive in nature. Metals are electropositive in nature because they have a tendency to lose electron, whereas non-metal they have a tendency to gain electron. Non-metal have a tendency to gain electron, so they are electronegative in nature. How a metal lose electron and a non-metal gain electron, let us see this with the help of an example. Okay, let us see this with the help of an example. We will take the metal as sodium Na, okay, and let us take the non-metal as chlorine. Okay. Now the atomic number of sodium is 11, whereas the atomic number of chlorine is 17. Now electronic configuration of sodium is 2, 8, 1 and chlorine is 2, 8 and 7, right. So the electronic configuration of sodium is 281, 287, KLM, KL and M. Now this M shell is the valence shell. The valence shell of sodium is having 1 electron and the valence shell of chlorine having 7 electron. To complete its octet, sodium, the atom of sodium, to complete its octet, either sodium has to lose, well, two possibilities are there. Either it should lose 1 electron or it should gain 7 electrons in order to complete their octet, isn't it? But sodium, it will lose 1 electron and chlorine will gain electron. Then the octet will be completed. Now let us see how it will happen. We will draw the electron dot structure of sodium. See here, which electron take part in the chemical bonding? Only the electron present in the outermost shell of an atom. Now how many electrons are present in the outermost shell of this sodium? 1. So I will make this 1 electron. Okay. Then chlorine. How many electron in the outermost shell? 7. 1, 2, 3, 4, 5, 6 and 7. Okay, 7 electrons are there. Now see here what will happen. This sodium, the electronic configuration I will write here 281 and this is 287. Now this sodium, it will lose 1 electron. Sodium will lose 1 electron. When sodium will lose 1 electron, then its configuration will become 28. Okay? It lose 1 electron, whereas the chlorine gains 1 electron. The chlorine gain 1 electron. So it will become 288. Now just you see here, the sodium, in case of the sodium, the octet is complete. In case of the chlorine also, the octet is complete. How it happened? By the transfer of electron. By the transfer of electron. Sodium lose 1 electron, whereas chlorine it gain 1 electron. Because sodium lose 1 electron, so it will become Na plus. It will form cation. Okay, it will form cation. Whereas chlorine, since it has gained 1 electron, it will form Cl minus ion. It will form Cl minus ion, right. This is cation, positive ion, this is anion which is negative ion. Now these two ions will be held together by a very strong force of attraction, very strong force of attraction. This very strong force of attraction between any two ions or between two atoms or between two molecules or between two radicals, it is called as the chemical bond. It is called as the chemical bond. These two ions are held together by a strong force of attraction, right. And here in this case, the special type of chemical bond between Na plus and Cl minus, it is called as the ionic bond. It is called as the ionic bond, very important it is. It is called as ionic bond. And the compound NaCl and the compound NaCl which is formed, it is called as ionic compound. It is called as ionic compound, right. See here, this ionic bond, it is also called as electrovalent bond. It is also called as electrovalent bond, right. And the compound, it is also called as electrovalent compound. The compound is also called as electrovalent compound. So when metal and non-metal react together, what type of compound they are forming? They are forming ionic compound or they are forming electrovalent compounds, right. Now one more example we can see. Let us take another example. When metal is magnesium and the non-metal is chlorine, let us see what happens then. When the magnesium is our metal and non-metal is chlorine, right. Now the atomic number of magnesium is 12 and the atomic number of chlorine is 17. Okay. Then electronic configuration 282. Here in this case it is 287 electronic configuration. Okay. Then I will make the electron dot structure of magnesium. That is, how many electrons in the outermost shell? 2 electrons. So, I will make 2 electrons here with magnesium. Then, how many electrons in the outermost shell of the chlorine? 7, KLM, 7 electrons. 1, 2, 3, 4, 5, 6 and 7 electrons are there. Okay. Now, see here, how many electrons is required by chlorine? Chlorine needs only 1 electron to complete its octet, right? I will write the electronic configuration here, 2, 8, 2 and here it is 2, 8 and comma 7. Now, this magnesium will lose 1 electron and the chlorine will gain 1 electron, right. Now, this chlorine has completed its octet, the octet of this chlorine is completed, but 1 more electron is there with magnesium. This 1 more electron that the magnesium is having, it will transfer this electron to another chlorine atom. It will transfer this to another chlorine atom, that is 1, 2, 3, 4, 5, 6 and 7. Transfer it to another chlorine atom. Now, this chlorine atom will also complete its octet and it will become 2, 8, 2, 2, 8, 8, right. And this has also completed its octet by losing electron. Magnesium being metal, it has lost 2 electrons and the 2 chlorine atom has gained this 2 electrons. Okay. So, the formula of magnesium chloride, it is MgCl2, 1 magnesium combining with 2 atoms of chlorine, 1 magnesium combining with 2 atoms of chlorine. And how to frame the chemical formula? I told you MgCl2 कैसे आ रहा है ये, मैग्नीशियम वैलेंसी 2, क्लोरीन वैलेंसी 1, क्रॉस कर दो MgCl2. I think by this your concept of framing the chemical formula is clear. Now, you can take down 2 important questions from this topic. First question, what would happen when zinc is added to ferrous sulfate solution? Write the chemical equation involved, right. What would happen when zinc is added to ferrous sulfate solution? Write the chemical equation involved. One more question you can take as your assignment, and that is show the formation of sodium oxide and magnesium oxide, right. You can take down these 2 questions and try to answer these questions. Okay. Next, let us study the properties of ionic compounds. Okay. Now, next let us study the properties of ionic compounds. Properties of ionic compounds. Now, see here, what are the properties of these ionic compounds? Ionic compounds, what are their properties? First, they are made up of ions. Ionic compounds, they are made up of ions. Next, second is their solubility. Second is their solubility. These ionic compounds, they are soluble in water. They are soluble in water, but they are insoluble in organic solvent like benzene, alcohol, it is insoluble in the organic solvent and it is soluble in the water. Okay. Now see here, when we take sodium chloride NaCl in the beaker containing water, NaCl plus water, if we take in a beaker, what happens? This Na plus and Cl minus, this ionic compound, the bond, the strong bond which is present between these two ions, that is the positive and the negative charge, the strong ion which is present, bond which is present between Na plus and Cl minus can break in the presence of water. It can break in the presence of water, because water has a very high dielectric constant with which it is able to break the bond present between Na plus and Cl minus. And what it will form, this water molecule will surround Na plus and Cl minus and it will separate these two ions. So we say that solubility, that is ionic compounds, they are soluble in water. Actually they are held together by very strong electrostatic force of attraction, but water is able to break them. Whereas if we take the organic solvents like ether, benzene, carbon tetrachloride, they are not able to break this strong bond. So ionic compounds are insoluble in organic solvent, whereas it is soluble in water. The next property of the ionic compound is high melting and boiling point. High melting and boiling point. These ionic compounds, they have relatively high melting and high boiling point. See here, the force of attraction between these ions. See, whether in the solid form or in the aqueous form, these ions are present. They are present in the ionic form only, in compound as well as in the aqueous solution. Now, since there is a very strong force of attraction between the two ions, so in order to melt this ionic compound or to vaporize it, we require large amount of heat. Large amount of heat is required in order to melt it, or in order to see its vapors, we have to provide them with high heat. That is why these ionic compounds, they have high melting and boiling point, because to melt them it required a lot of heat energy, right. Okay. Now next property of ionic compound is its state, physical state. The physical state of ionic compound, they generally exist in the solid state. They generally exist in the solid state because of the presence of the strong electrostatic force of attraction between the two ions. These two ions are held together very tightly, very compactly they are held together. So because of the strong force of attraction, they exist in the solid form, right. Now next property is that conduction of electricity. Next property is conduction of electricity, right. See here, in the solid form, these ionic compound, they do not conduct electricity. When they are present in the solid form, they do not conduct electricity, but when they are present in the aqueous state, that is a state mixed with water, you can write down mixed with water. When they are mixed with water, they conduct electricity. That means in the aqueous state, they conduct electricity, and also in the molten state. In the molten state also, that is when they are melted, they will conduct electricity, right. So this is regarding the properties of ionic compound. They are made up of ion, their solubility, soluble in water, they are having high melting and boiling point. Then physical state, they exist in solid state and they conduct electricity when mixed with water and in the molten state. right. Now you can take down one more question from this topic. I will write the question here, please take down this question. Why do ionic compounds have high melting and boiling point? Why do ionic compounds have high melting and boiling point? Okay. So children, I think this much is enough for today, and we will continue in the next class. Thank you.